questions, I will try to answer. In this talk, I will not show you a single line of code. And this talk is not a lecture about machine learning. And I will not go to the nitty-gritty details about the technology I use to implement the system. Instead, this talk is about, I like to show you in this talk that even though Drupal is a CMS, it's not only limited to a CMS. You can use a lot of other external programs to make it work with Drupal and do all kinds of amazing things. In particular, in this session, I will cover these 5 topics. First is about a very brief introduction about machine learning. And I will show you the algorithms I use to classify political articles. The next is some introduction to the case study, some background. And then I will discuss the technical choices about implementing the system. The main piece is the system architecture. I want to share with you about how to make Drupal work with machine learning libraries. Finally, I will give you a list of the Drupal modules that you might find useful to use in your own site. This work comes from a chapter of my dissertation, and these are the people who helped me. If I use we, these are the people. So a little bit about myself. I graduated from the University of Michigan in 2013 from the School of Information. And then after that, my main job was to build some startups as an entrepreneur. On the side, I'm doing some Drupal consulting work to pay the bills. And in real life, I'm a father of 2 lovely kids and live happily in Ann Arbor. That's about me, and we're back to business. The first part is a very brief introduction to machine learning. So this is the definition of machine learning. It's copied from Wikipedia. I'm not going to read it to you here. I'm only going to emphasize 2 points. So a machine learning program, it has to learn from data. And also, it has to make some predictions. Before the talk, I talked to a person, Mike. He mentioned about he used Drupal to automatically use rules to respond to send some emails. But that's not a machine learning program because the rules he created are predefined. For machine learning programs, basically you would train some algorithms, and then the algorithm would automatically create rules for you so that you can have some new rules automatically generated from the program to send those emails. That would be a machine learning program. And the term machine learning is also sometimes confused with big data. Big data is a popular term these days. For big data, it doesn't have to make predictions or do intelligent stuff. Mostly for big data, you just have terabytes of data so that you can perhaps gain insights or make data visualization. But big data also deals with machine learning sometimes. For machine learning, it just do these things. It doesn't have to be big data. So that's the definition of machine learning. And next, I'm going to show you a few examples about machine learning programs, about how I use those programs to classify the political leaning of articles, to give you a basic idea of how machine learning programs work. The first example I'm going to show you is called SVM. It's called a support vector machine. It's one of the best classifiers out there. So the first program I used to classify political leaning of articles is this algorithm. Basically, to use this algorithm, it has to go through 2 steps. The first step is that you have to train the classifier using human label data. You have to have real people label some political articles into a conservative and liberal. And then you use these labeled articles to train a program so that the program will understand how to classify new articles into conservative and liberal. The next step is that you classify new articles using the trained classifier. So it's a two-step process. So here's how the training process of SVM works. So we start from a few political articles already labeled as red and blue to use conventional, the conventional thing. I color-coded the conservative as red and the liberal as blue. The first thing to do is to parse these articles into a bag of words. The frequency of certain terms appears in those articles. And then you would map this bag of words into some vectors in a pure mathematical format. From these vectors, you can map it into a multi-dimensional space. To make it a little bit easier to see, I just use this two-dimensional diagram. Basically, you can see that each dot on this diagram represents a political article. From those articles, you just plot these dots on this diagram. The smart thing of SVM, this algorithm, is to find the cut so that once it has this cut, it will know that all the articles that falls on the upper part of the diagram would be classified as red, and those articles that falls in the lower part would be classified as blue. After this process, basically, you have trained the algorithm so that it understands how to classify new articles. So the process of classification would be like this. So you have some articles that you don't know their political leaning. And then you do the same thing about making them into a bag of words and making them into the vectors, and then plot them on this diagram. So if this article falls on the upper part, it's going to be classified as red. And if it falls in the lower part, it's going to be classified as blue. That's basically how the SVM algorithm works. Yes?
Sorry, what are the axes representing on that graph?
The axes are just dimensions of this vector. It usually should be a multi-dimension, maybe hundreds of dimensions. But just to show how it works, I just use 2 dimensions. Does that answer your question? It's going to be something. So the intuitive explanation is that each keyword would represent a dimension. You can use some dimension reduction technology, but that's some more advanced.
Frequency of use of that keyword?
Kind of.
That's fine.
Yeah. So that's basically how SVM works. It's pretty popular algorithm. The nice thing is that there are a lot of open source libraries for this. So you don't even have to, you just need to kind of understand the intuition, and then you just use the open source library to do this. You don't have to implement the whole algorithm yourself. The next example of the machine learning algorithm I use was particularly designed to help us classify political leaning of articles. It's called the graph propagation algorithm. So basically, for this algorithm to work, we have to have both the articles and some users who read these articles. So, for example, we also started from some articles that's already labeled. We need to construct a graph from this data. This graph, a link between a user and the article, is something like it's a signal to show that this user likes that article. It could be a tweet mention. It could be a share on Facebook, or it could be a Reddit vote. So basically, if a user likes an article, and if that data we can get, we can construct this graph out of it. The way we do the classification was to propagate the political leaning of articles to the people. We assume that if a user likes an article for some reason, they would share the same political leaning. And then we do this propagation one step at a time, and then we can classify all the articles and the users in this graph. The particular algorithm we designed was to handle this particular case where there are multiple, there are people from different sites who like the same article. How are we going to classify this article in particular? That's how the algorithm worked. So that's the second algorithm we designed. Some of the notes here. One is that the classification algorithm don't always give you the correct answers. the way you evaluate a classification algorithm is to see its accuracy. So for example, you have a couple of articles you already know they're correct political leaning, and then you run the algorithm against it and see if the algorithm got it correctly. The two algorithms we had, the best one can give us 96% accuracy. And another thing is that usually for machine learning algorithm to work, you have to give it some human labeled articles items for training purpose. You will see that is indispensable part for the system I'm going to show you later. And also, there are a whole bunch of machine learning libraries that are open source that you can use to do smart things. For example, if you want to have the algorithm automatically create some rules for you, you can take advantage of these libraries and do it for you. And finally, there are some very nice online courses to teach you about machine learning. If you're interested, you can find them on Coursera and Udacity. Coursera ones are free. Udacity paid, Mike has told me. But if you're interested, those are very exciting courses you can take. That's about machine learning. Next, I'm going to give you a few introduction about the case study. The work we've done was called the Balance Project. It was NSF-sponsored research where we're trying to figure out how to reduce the increasing political polarization in the society. This diagram shows that conservative bloggers almost always link to other conservative bloggers, and liberal bloggers almost always link to other liberal bloggers. And other research have shown that people usually want to talk to like-minded people. Conservative people want to go to the same bars other conservative people go to, and they go to similar restaurants, read similar books. That's a problem for democracy, because the more you talk to like-minded people, the more polarized you get. And then usually you would refuse to listen even valid points from the other side. Our research was trying to figure out ways to make the two sides talk to each other and reduce polarization. Our proposed approach was this website. It's basically a political news aggregator to pull political articles from all over the web. And then we want to show readers a balanced mixture of conservative and liberal articles, so that you don't always read articles that agree with you. We want to have you read a few articles that don't agree with you. But of course, we have to do the political leaning classification first, so that we know which article are conservative, which are liberal, so that we can feed those articles to you. This system serves many research goals, which I'm not going to cover in details, because this talk is about the system, how we build the system. The system was fully functioning at the end of 2012, but as of now, it's offline and archived, which is the fate of many research projects. So I'm not able to show you a live demo, but hopefully the content is still helpful to you. Next, I'm going to talk about some technical design choices. First design choice is why Drupal? This is a pretty simple question for us, because the site we were trying to build was basically a content site, and Drupal was obviously the best choice. And then the next design question was whether we should go all Drupal or do a hybrid using Drupal and other programs written in Java and Python. If we use all Drupal, that means we have to implement the machine learning algorithms in PHP. The thing is, PHP is not really designed for machine learning purposes. It has quite a few limitations, such as RAM limit, and also it will give you timeout from time to time. The worst of all is that it doesn't have any library support for machine learning libraries, where you can find all kinds of libraries written in Java and Python and C. So PHP is not the choice here. We have to go hybrid, use Drupal and other external programs. The next design challenge would be how to make Drupal work with those external programs written in Python and Java. there are a couple of challenges here, which are going to be the main topic I'm going to discuss in the next part. So the main part of this session would be the system architecture of the site we built. So this site had 4 components. The first one was fetch. We want to crawl political articles from the web and aggregate them in our own site. The next part was called label, where we have to label a few political articles to feed into our classifier, train the classifier, so that we can do the classify part to classify a large amount of other political articles into conservative and liberal. And lastly, we want to display the classified articles to the end users to make them consume a mixture of conservative and liberal articles. Next, I'm going to get into each part in details. Any questions so far? Okay. So the first part, fetch. Usually, people would use the feeds module to crawl articles from the web, but we use the dig API. Dig was kind of similar to Reddit back in the days. It experienced a reboot, and they don't have public API anymore. But back then, we can use their API to get all the popular political articles, and also we can get which user liked those articles. It worked perfectly for our graph propagation algorithm. That's why we use dig. And then using the dig API, we crawl the articles and save them into an external database. And then we only save the links of those articles. And then we use the diffbot API to actually get the content of the articles. Diffbot does not only give you the content of the website. It kind of strip out all the HTML tags. So I give you a very clean, pure text article. It works pretty nice. The reason we want the pure text article was because when you train the classifier, you have to give it the pure text. Otherwise, the HTML text will mess up the classifier. And finally, once we have those pure text articles, we use the Drush script to create nodes into the Drupal system. This was a pretty straightforward process of getting the articles. And then the next step was to label some of these articles in order to train the classifier. And also we wanted to have some very good, accurately labeled articles for academic research purposes. The challenges, though, was that there are a lot of articles we have to manually label. At the end of the research, we had like 10,000 articles we labeled. If I'm going to do the label, or if I hire a bunch of people to do the label, it's going to be a lot of work. And besides, new articles come into the system every hour. We need people to classify those articles, to label those articles right away. I cannot monitor the site every hour to label new articles. So the solution we used was to use Amazon Mechanical Turk. This is a microtask crowdsourcing platform. So basically, with Amazon Mechanical Turk, you can post paid jobs on this platform, and then thousands of people on the platform will do those jobs for you. Amazon Mechanical Turk is a little bit different from other outsourcing sites like Odesk or Freelancer, because this is what's called a microtask crowdsourcing. For a microtask crowdsourcing site, you basically pay workers by piece. For example, I pay one worker 5 cents to label one article, and they get paid these 5 cents after they label this one article. If they want to label more, they can continue to work on this task, but they can stop anytime and just take those few cents. So it's typically designed for that purpose. Other usage of Amazon Mechanical Turk is that you can have workers just go to any website and grab the business address for you on those web pages. It's also paid by piece. You pay them like 10 cents to do one web page. Other usage, like in the library people use Mechanical Turk to clean up their library collection metadata. So it's pretty useful. Another feature for Mechanical Turk is that you can have hundreds and thousands of people working on your task simultaneously. You don't have to go through a hiring process to hire those workers. Basically, you post your job on this system and design a very simple qualification test. Once the worker passes those tests, they can work on your task right away. And then Amazon handles the payment, pay them a few cents per task. Another feature on for this platform is that you can fully program the entire process so that there's no human intervention. You as the employer doesn't have to do any intervention while they do the work. So in that sense, this platform is sometimes called human computation. So basically, you treat those human workers as a computing resources, not as a typical employee. You just give them tasks and they do the task for you. So we use this platform to label the articles, the 10,000 articles for us. This was how it worked. So once we get those articles, crop those articles from the web, we have a rules action that automatically posts the link of the article to Amazon Mechanical Turk. And then Amazon Mechanical Turk will expose those articles to the workers, to the qualified workers. And then the workers, if they want to do the label for us, they just start doing those tasks. What happened was that they opened a browser and they see Amazon Mechanical Turk. But what actually worked was that there was an iframe that show our web pages, and we used web form to collect their labels. So basically, they open the Mechanical Turk web page and they do the labeling work on our website. And finally, when they are done with the work, when they submit, our Drupal site will post a signal to Amazon, telling the platform that the work is done, and Amazon, you can pay those workers. And then Amazon will handle the rest. Finally, we have a small module that takes the web form results, takes their labels, and save those labels into the article. By the way, the political articles were saved as a node in the Drupal system. And we have a field that we created a field to for the political lineage of the article. So the cleanup phase was to get the label from the workers and then save it into that field. So that's how we use Mechanical Turk in the system. This process is fully automated. So every hour there would be 30 articles coming to the system, and they get posted to. Some of them get posted to Mechanical Turk. Usually we get labels after 30 minutes. We get some of these articles labeled. So that's this part. Any questions so far? Yeah.
To go back to the PHP machine learning part, is there any technique for reducing the memory footprint of machine learning algorithms?
No. The typical approach, if you already have pretty big data, the typical approach is to throw in more computers. Big data typically handles that. You use a big cluster with like hundreds of thousands of computer nodes and do those things for you. I guess the typical consensus was that developers' time is also pretty expensive, and you would rather throw in cheap hardware instead of optimizing your process. So if you already have a large big data, you would want to use a cluster somehow. There are research about trying to improve the performance, but the typical process is to throw in more hardware. Yes?
The site that does this fetch and integration with labeling, is that the same site?
It's the same site.
For the classification where for new articles that doesn't go through the labeling process?
That's a good question. I will show later that the classifier can reside in a different server. Although in our research we use the same server because we are under budget. But the architecture would allow running differently on a different server in a distributed computing environment. Any other questions?
Yes. Next up for the label, the iframe web form.
Uh-huh.
Are there any issues with the humans putting in data or not, any errors or anything? Is there a percentage for that, or how do you account for that?
Yeah, some of the caveats of Amazon Mechanical Turk is they are really spammers. They just want to earn that 5 cents and walk away. They hope that you don't catch that. And there are fair bit of amount of research trying to solve this problem. So what you would usually do is that for each article, we had four people label the same article, so that then we can compare within each other. There's an algorithm that can compute their trustworthiness, and also the final label. It's a little bit more complex than majority vote, but there's algorithm designed for that purpose. And also another caveat is that we could have paid the worker 10 cents to label one article, but instead we paid them 5 cents. The reason was that research have shown that if you increase the money you pay to those workers, it doesn't give you better quality results. It only makes your work get done faster. If I pay them 10 cents, I did an experiment. I paid them 10 cents. I get the articles get labeled in 10 minutes. I pay them 5 cents. They get labeled in 30 minutes. But the quality is about the same. So basically, if you pay them more, it's gonna get you work more, but doesn't necessarily mean they work more accurately. So that's some caveat about using Mechanical Turk. If you don't have any other questions, I'll move to the next step. So the next step was to actually classify a big amount of articles that are not classified, that we don't have resource to manually label them. Recall that we have these two classifiers, which were written in both Java and Python. For the purpose of this session, I will just focus on the SVM classifier. There were a few challenges to make those classifiers work with Drupal. The first challenge was how to read and write data from and to Drupal. One option could be that you use files in the file system, where Drupal export data into a file, and then your external program just read data from that file. The problem for this option was that you have to figure out coding encoding problem for the file, different file format, and it's not very flexible because there's some external files involved. Another option is that you can have your classifier directly access database, directly access Drupal database. This approach only works if you have your own table. You don't want to directly read Drupal related data from the database because Drupal has a fairly complex caching system. If you read or write data, the chances are that you might mess up with their caching system. So that's also not a very good approach. Another approach, which is pretty commonly used, is to use the services module. The one thing that didn't work with services is that for every data you want to get from Drupal, most of the time you have to write your own service endpoints. I mean, except for the nodes or entities. You have to write a lot of services endpoints to get particular data from Drupal. Another possible option was to use a Drush pipe. Drush has this pipe option where it can export data into JSON format. It doesn't have to be human readable. It can export data in Drush in JSON, and then your program can take those JSON as data input. I'm gonna talk about how I did that, but these are a few options. Another challenge was how to trigger execution of the external machine learning programs. One option was to use the PHP exec program. That's really not a good way to do this, because if you execute external system command, it might crash the PHP system. What people usually do was to use a message queue system, which is usually a worker producer queue. The typical way of making it work is that Drupal will behave as a producer and create a kind of a job in this queue, and then your machine learning program can take that job and execute it and save results back into the queue, so that Drupal can take it later. The only drawback for this the message queue approach was that you're gonna involve third-party programs, which are not gonna be very tightly integrated with Drupal. I'm going to talk about how we did this. Our solution was to have a contrib module that mimics a very simple worker-producer message queue through the use of this computing record entity type. So each of these computing record is a Drupal entity and runs inside of Drupal. So whatever you can do with a Drupal entity, you can do with computing record. And this entity basically serves as the interface between Drupal and your external machine learning programs, where Drupal just saves data in the JSON input field and pass to the external programs, and the programs do some calculation, put data back in the JSON output field. I will show you how that works in our system. So basically, we have some data. Some of them are labeled, and then we have a Drupal piece of Drupal code that export the articles data into the computing record entity. This all happens within Drupal, inside of Drupal. The rules action there was that whenever we have like 100 articles, it's automatically triggered to do that process. And then the SVM classifier would just periodically pull new record from Drupal through both Drush interface or services interface. In our system, we used Drush, but the services was another option. The endpoint for services was already written for computing record, so you don't have to use write new services endpoints. It kind of simplifies this work. And then once the classifier gets those data from the computing record, it does all the classification work. And if there are a lot of new label data, it can retrain itself so that it can classify better. Just to answer that question, this classifier can reside in a different server, although in our site, we make it working on the same server. And once the classification was done, the results were saved back into the same computing record, and then the classifier would mark the record as done, which then triggers another rules action for Drupal to take those classification results and write it back into the articles node, the field which saves the political leaning data. So this whole process was also fully automated. So once a new article came into the system, it's going to trigger all this process, and you get articles labeled as either conserved and labeled and saved in the Drupal database. The benefits about using this workflow was that first, this was reusable. No matter what classifier or machine learning libraries programs you're going to use, you can use the same architecture to do this. The next thing that is nice is it's pretty agile. Whatever data you want to pass to the machine learning programs, you just save them in the computing record without having to write a new services endpoints. So you can basically pass any data to your external programs with relatively little work. Another nice feature was that the computing record entity was tightly integrated with Drupal so that you can use views, rules, those type of powerful things in Drupal. So that's the classification process. Any questions so far? Yes.
How did you determine that 10,000 records was appropriate number for your training set?
We kind of that was arbitrary choice. We kind of run this program for 3 months. At the end, we have like 100,000 articles. Just 1/10 of them are manually labeled. We need those manually labeled data because we're running other experiments, like how to make some designs to push people read some articles from the other side, where we need to use accurately labeled data in order to help us do those research. So it serves some other purposes, but basically that's an arbitrary number we used. There are some systematic way of helping you decide how many label data you should have to train your algorithm, but that's going to be another topic. Thanks for the question. Any other questions? Yes?
So the human manually managed data is sort of a control that when it feeds into this, I'm just trying to make sure I understand it right. That by the time it gets to the classifier looks at the article and says, 3 out of 4 people label this as conservative. I know what the bag of words looks like. I now put this together and I understand that these words mean this is conservative.
Yeah, that's the training process, exactly.
Okay.
Yeah.
And after a while, it has a good feel, and then it just automates, and I assume accuracy just increases, and it's great to go.
Yeah. But if you give it more training examples, if you give it more human labeled data, it can even increase accuracy even more.
Yeah.
So that's why when we have the label data continuously feed into the classifier to make it retrain itself and classify better. But you can also just take a few labeled data, train the classifier once, and then classify the rest of the articles. Okay, if there's no other question, I'll move on. The last step is to display the articles. So we have 2 types of articles displayed to the audience. First, we have a personalized homepage. We basically show a balanced mixture of conservative and liberal articles. If you're liberal, you would see some conservative articles in the homepage. And if you're conservative, you would see some liberal articles on the homepage. That's the first thing we did there. Another thing we did is per page recommendations. So it's a typical people who read this article also read type of thing. But we have a twist that for liberal articles, instead of showing any people who read this article also read, we only show that conservative people who read this article also read. And if you're a conservative user, we would show other liberal people who read this article also read. So it's kind of a way for you to read articles on the same topic, but from the other side. That's how we display the articles. So that's how the system was architected. Finally, I will summarize the talk by listing the modules I used in the case study. One is the Drupal computing module. It's particularly designed to facilitate distributed computing between Drupal and your external programs called engine. The way it works is kind of like what I already showed you before. You basically export data, Drupal data, into the computing record, and then your engine program pulls data from those computing record entities through either Drush or services interface, and then your external program process the data and save the data back to the entity, and then the Drupal will handle the data from the engine program and make it integrate with Drupal. So that's what this module does. It helps you do this whole process of making Drupal work with external programs. Some of its features is that the computing record entity is a simple message queue that tightly integrates with Drupal so that you can use rules, views, and entities. And also, this module comes with some reusable Java and Python libraries. If anything, you can just use these libraries to access Drupal. It's a reusable Java and Python code so that you don't have to write your own to use services, for example. those Java and Python libraries are hosted on GitHub instead of on Drupal.org. I would recommend this module if you want to make Drupal work with external programs. Another module I'd like to share with you is the recommender API module, which kind of does the people who read this article also read other articles. I recently published a new release for this module. So now it comes with two engines. One is the PHP engine and the other is the Java engine. If you only have a small amount of data, you can just use the PHP engine and everything works out of the box. You don't have to set any external programs. And you can have the PHP engine do the computation, generate the recommendations. However, if you have a large amount of data, you would have to use the Java engine, which could run on a different server and use a lot of resources to make those recommendations. But it's your choice. You can use either engine. So that's the URL, and I have a walkthrough there to show you how you can very easily turn on people who read this also read the other articles. Another module from that case study was the Amazon Mechanical Turk module. The goal of that module is to fully automate Drupal to integrate with Amazon Mechanical Turk. Still a work in progress, and the chances are you're not able to run this out of the box, but you have to do some customization before it can work. I'd just like to throw in a couple of ideas of how to use this module and how to use Mechanical Turk. For example, if you're doing a community website, you don't want your new users come to your website and see a blank page. You want to have some content before you get users to your site. Then you can use Amazon Mechanical Turk to generate some content for you in your community site. Another example would be if you're building a rating site. You don't want all the ratings to be blank when new users come to your site. Then you can use Amazon Mechanical Turk, hire hundreds of thousands of users to generate some initial ratings on your site, so that when your new user come, they can already see some ratings on the site. Another use of the Amazon Mechanical Turk was to do typo correction, like the metadata. Suppose you're building a site for a library, and the library want to clean up their metadata. You can use Mechanical Turk, hire thousands of workers to go to the system and do the typo correction for you. The reason you hire those people, I've already mentioned before, is that they do this simultaneously. Hundreds of people can do that at the same time. And also it's pretty cheap. Usually one piece of work costs 5 cents, 10 cents. It's pretty cheap. Another thing that I use pretty regularly was to do a site testing. So whenever I launch a new site, before I launch a new site to the clients, I would have like 50 Mechanical Turk workers go to the site and do some simple things with the site, just to see if there's anything breaks. I usually pay them like 70 cents to do this, to do a 10 minutes run through on the site, see if the site works well. Also, you can do usability study. You pay those workers to come to your site and do some evaluation for your site. So Amazon Mechanical Turk is a pretty useful tool. I would recommend you take a look at some point. Another thing is the text analysis suite. I was trying to make the SVM work with Drupal out of the box. I haven't even started working on that yet. But all the machine learning libraries are out there. What's need to be done is to make it integrate with Drupal. You can do all those exciting things with those libraries, like content classification, like I just showed you earlier. There are some other machine modules on Drupal designed for you to use machine learning capabilities. Most of them are cloud-based. For example, Alchemy API is a text analysis web cloud service. you can use to do the classification. Although it's quite limited, it only allows you to classify content into 9 predefined categories. But it's out there, it's easy to set up. Aqualift is another web service you can use. Some comparison between cloud service and in-house programs. What I showed you earlier with the case study was all in-house programs. I built the thing and run it on my own side. So if you want to choose between cloud service and in-house programs, basically it all depends on your business need. If the machine learning programs are core to your business, you might want to use in-house programs because you can customize it, and also you own the data. If you use cloud service, you have to export your data some way to the cloud. But it's easy to use. If you have some optional features, cloud service might be a better choice. I hope this talk gave you an idea that even Drupal is a CMS. You can do all kinds of things with it, and greatly increase its capacity by integrating other external programs. The possibilities are limited. With that, I'm gonna take questions. Thank you. Yes.
Question about, you were talking about earlier on about classification and stripping out the markup, the HTML markup. Curious is if that's still the case, because there's, with the advances in HTML5 markup, some markup is actually fairly, can expose
semantic.
Semantic meaning. Well, not just the markup, but also microdata that could be embedded in an article might help to.
It has to depend on your classifier. If your classifier is aware of those semantic tags, it's gonna help you do the classification. But none of the open source libraries I know of are able to take care of those semantic tags. So perhaps at this stage you might still want to strip out the tags. Yes, Mike?
Are there considerable differences and say challenges with text analysis across other languages? If you're going to do this with the Chinese article?
Yeah, one of the main challenge of other languages like Chinese is to break down languages into different tokens. Because Chinese is a language where it has single characters, but different characters can make up a word. How do you break them down is another challenge. But after that, when you map those languages into mathematical vectors, the rest is going to be the same. The challenge only comes between the bag of words and the vectors representation. That's where different languages might be a problem. Yes?
Was the decision to go on political leanings a decision that stemmed from the team structure, or was it personal interest?
Our research was about how to reduce polarization. So political leaning classification is the first step we do for that research. So it's a research requirement, I guess. But our research team, all of us are pretty interested in this domain. Yeah. Any other questions? Yes?
I think political articles are probably one of the most challenging things you could possibly touch, which is amazing that this worked so well. Just the nature of liberals bashing conservatives, conservatives bashing liberals.
Yeah.
It happens, let's get real.
Yeah.
How does the system address those sort of things? For example, Obamacare is a liberal activity going on that conservatives don't care for, so they may mention that a lot. How does it know that that is a negatively charged approach to that highly saturated word?
That's actually a good question. I don't think I have an answer for that. The whole research was to think about these challenges and design ways to reduce polarization. I don't think so far we have got that. The research result was that using certain designs, it can nudge you read a little bit more articles from the other side instead of just reading articles you already agree with. some designs like when I show you articles from the other side, I also show you articles from my side as a reinforcement, as something safe for you. We have some results, but that's definitely a good thought. And unfortunately, I don't have an answer for that. Yes, Mike.
So were you able to get like a final accuracy of the model, like how how well it actually could classify these articles? Like, I mean, you compare against like a human or something and say, oh, you know.
Yeah, the tricky thing is that even humans don't get it right sometimes. But if you compare different classifiers, the gold standard is still human input. Even though human made some errors, when you evaluate different algorithms, you still compare to human input, which is the gold standard. The graph propagation algorithm shows higher accuracy. One of the things you have to do with designing an algorithm is to evaluate their performance. Accuracy is one of the most used metrics to evaluate the algorithms. I think the time runs out, and if you have questions, feel free to come to me. I'm happy to chat with you. Thank you, guys.